SRI International in Menlo Park, California. Signing in through the security guard in front. Have to be in the system, give them at least a 24-hour notice to get in.
10 times greater than the energy density of a chemical reaction. That's what makes it important.
I see. All right. So we can't really get away from that.
Well, for Joe's six-pack, we don't have to say nuclear, though.
Well, which is what the reason. And the problem I have with acronyms is this field has spawned more acronyms than any other ever. I would think there's got to be at least 30 operational acronyms. Everybody that enters the field comes up with a new acronym, and it's becoming a bit of a joke.
Because they want to separate themselves apart from everybody else.
Well, and their idea, of course, is more on target. And Mitch Swartz jumps up and down about LANR because he thought of that and insists on it, to the point of it becoming
Mitchell Schwartz's reaction.
Yeah, funny, sort of funny in a tiresome way. And every one of the International Advisory Committee meetings that we sit in, somebody comes up with, well, we've got to get the nuclear out of the name, and we worked hard. CMNS does have N in it, but nuclear science is a little kinder sounding than nuclear energy. But you get to call it what you want. Controlled electron capture, I'd be happy enough with that. But comes the time for licensing, and the authorities get involved, there's no disguising the fact that the power and strength of this effect is its nuclear parentage, and that is the thing that makes it important. If it wasn't nuclear, it wouldn't be important. Unless you believe Blacklight Power, who are going to run a demonstration on the 28th of January, producing 10 megawatts from a 1-foot cube.
Yeah, got a note on that one this morning.
Really? Where's that?
Anyway.
So, I don't know, at a certain point we are going to have to front up to the fact that this is nuclear, because if it isn't nuclear, it isn't important, unless Randall Mills is right.
Where he's saying it's not nuclear, and I'm going to put
He
10
insists
megawatts.
that it's not. Insisted that it isn't nuclear, and has some sort of chemical proof that it is a very strange form of chemistry. But the problem, of course, is for chemists, we're willing to fiddle with the laws of nuclear physics. We're willing to acknowledge that the nuclear physicists have made a fundamental error somewhere, but we're not willing to admit that the chemists have made a fundamental error somewhere. So if you say it's new chemistry, you'll get more pushback from the chemists than if you say it's new nuclear.
It's interesting. Of course, I think the better selling point is if he's right. I mean, if he can do the reaction, that's one thing. If his hypothesis is correct, is the real proof that it's not nuclear, that you can get those energies from non-nuclear reactions, but that's much harder to prove.
Yeah, but you're saying that the nuclear has been an easy win to change the terminology, and it seems like the nuclear field has been kicking and screaming about anything outside the box, LENR or otherwise. Mm-hmm. And you're saying it's going to be a harder sell to the chemists?
The idea that what Randy has proposed is that the atom that chemists know best, that was originally studied, its spectroscopy, that defines chemical spectroscopy, the hydrogen atom, that the ground state of the hydrogen atom, the very bottom level from which to which everything goes, is not the ground state. That we missed something. That in fact the ground state sitting up on the top of the Empire State Building, and there are a whole bunch of other ground states below it that are accessible. And to a chemist, this is it's heresy. I mean, this is a religious argument. I mean, this is something that the first page of your textbook teaches you. Every one of your teachers has taught you, and if you'd ever said anything other than that, you would have failed. So Randy's proposition was, to me, more absurd than Martin Fleischmann's proposition. You know, I can see how two deuterons can get together and make helium-4. I don't know the mechanism, but I accept the thermodynamics of that process. What Randy was proposing and continues to propose, and has raised a lot of money on this proposition, is that you can access lower ground states in the transition to lower subquantum, fractional quantum, the half state and the third state and the quarter state. It's the quarter state that he's particularly interested in, and that is accessible, and that there's energy available from it, and that there's evidence for it in the energy that comes in from the universe. That it's the spectral lines that he predicted are amongst the handful of lines that we observe from the night sky and can't explain. So he has experimental support for it, and I paid attention to him for a while. And it's just because it's outrageous doesn't mean that it isn't right.
Mm-hmm.
Of course, the proof of the pudding is in the eating, and on the 28th of January he's going to demonstrate 10 megawatts from a 1 foot cube. Whatever happens is going to be spectacular and would absolutely be worth attending.
Are you going?
No, I'm going to be in Italy then, but
Talking to Chilani?
Is anybody from SRI going to attend?
Is anybody from the East Coast part of the community going to attend?
I've asked that question and nobody's answered yet.
Yeah.
So what does it mean to you? What does this pending event mean to you?
It's sort of huge. It's put up or shut up time maybe for Randy, because he's raised a lot of money. He's
Right.
raised 60, 70, 80 million dollars.
80.
Yeah.
80.
And has had a lot of people working and has had some demonstrated successes. He's had presentations at American Chemical Society meetings, and but the stuff they've talked about in terms of energy, they've talked about big energy gain and big power gain, but that's for systems with very small denominators. So the multipliers looked good, but the numbers were
Small.
milliwatts.
Right. So now he's going to go do 10 megawatts with what kind of input power? Nothing.
Well, it can't be much.
Mhm.
Just getting 10 megawatts, a tenth of that, a megawatt of input power would be a pricey proposition. So, but he claims gains of 10 or more. What might happen, I'm not predicting this, it would be unfortunate, but everybody shows up and they have some sort of technical failure and are unable to perform the experiment. That would be unfortunate. And it doesn't make us look good either. But if he succeeds, I think that's good for everybody. It means there's energy there.
Right.
Now all we have to do is figure it out and work with it.
Right.
So I wish him every success.
Yeah, I mean, we don't know what the mechanistic answer is. So if his is right, it helps the rest of us.
So you think that his success has spillover into the LENR field in general?
Yeah.
Mm-hmm.
In the beginning, he
Just
was
because it's
both.
exotic and they're all exotic, or?
Well, because it proves that energy is accessible on a useful scale.
Mm-hmm.
There's a engineering product accessible here. And I've always argued that the people who are sole proprietors, and Robert Goddard, for example, it's his invention, it's his baby. He wants a win and views others as competition. The Defcalian guys wouldn't let me come up and visit them because I'm associated with Brillouin.
Oh.
And because they believe that it's a competitive environment. It is not competitive, cannot be competitive. If one succeeds, many will succeed. This cannot ever be allowed to be a monopoly. One group, one concept, one idea, one company, one country will never be allowed to own this solely. It must always be spread between, several different technologies. Otherwise, it's not stable. Wars would be fought. People would be killed. It's much too important to let any one person control it.
What if there's only one engineering effort that does succeed for a while and, comes out with something that's commercializable, leapfrogging ahead what everybody else is doing because other people say are stuck in the mud? What if that happens? I mean, why is that a bad thing?
It doesn't happen. It doesn't even happen for little things. It didn't happen with the iPhone, for example. Everybody's making an iPhone. And that was...
Yeah, but nobody's done this before. Nobody's commercialized this before.
Well, it's a binary question, a series of them. Is it commercializable? First, is there anything here? I think there is. Is it commercializable? I think there's a good shot that it is. If the answer to those two questions is affirmative, then multiple technologies will spin up. Other countries will not tolerate it being in the United States, or
They'll rush to figure it out.
yeah.
You're just saying sooner or later there's going to be a bunch of people doing something similar or something that works
Has to be.
around the
It has
field.
to be, and it's sooner rather than later. It's inevitable.
Mhm.
But and energy is such a big business opportunity. I mean, energy is everything. There isn't anything more important than energy.
Sure.
Given energy, you can create money, you can create water, you can create health.
Right. Right. No,
Improve standards of living.
Yep. Yeah, it's incredibly important. So, for everybody who's watching this video, if you don't understand science but you're wealthy and you care, you should come and sit down with us. Because do you really have something more exciting to spend your money on? These are the most interesting people in the world to hang out with, at least part of the time. Well, as far as I can tell.
This is the most close to commercial of anything that we have worked on. And there are very few competitors.
Presently.
In Rossi, maybe, Vifkalian, maybe, Blacklight Power,
Blacklight, maybe.
maybe. That's the playing field right now.
Yeah.
Anything that leaks worse is helium. And those are the two gases we're most interested in, one keeping in, both keeping in. So machining to seal hydrogen is, it's difficult. And pretty much only a metal seal works. That's just the conflat that you see in the middle is the active seal is a knife edge onto metal.
So hence the tolerance.
Right.
Okay, to be able to have those really.
This is the third version, and we said that we've been working on it a year. Most of it has been basically preventing leaks and reducing the number of problems and actually running the tests.
And there's probably no gasket you could use that would help.
It's a metal gasket, but you need to exert force on it. That's why you have that ring of bolts.
Mhm.
So there's actually, Frank can show you one in the lab, there's a flat copper, sometimes silvered copper disc, and the stainless has a knife-edged ring, so you pinch it down, it actually cuts into the metal. So there's a metal-metal bond is formed mechanically, which is the only way you can seal against hydrogen.
Yeah, it seems like a clever way to do it if you get a metal that has some give, so that by the time it gives, it sealed makes a complete seal. But how thick are you looking for to have the distance of that seal?
Oh, these discs are like 1/8 of an inch thick, but you only cut into them 10,000th of an inch or something. It depends how much you winch on it.
Well, but these things, when these two plates come flat together,
Mm-hmm.
they're
Right.
only cutting in maybe 1/10 of the thickness of the copper gasket. So, and you essentially can't tighten it any more than that. You can't cut in any more than that.
From a commercialization point of view, how is it going to be to try and create something of this ilk on a, mass production level.
You don't do it that way. You weld it.
Yeah,
All
okay.
welded systems.
This will be a welded, not a bolted together system. This is
Yeah.
so we can take it apart and change the cores we talked about earlier
Mm-hmm.
to do the experiments that Mike and Fran have been talking about. Because we've got a variety of different core.
So the experimental level is very difficult, but a commercial level would be easy, relatively speaking,
The problems have all been worked out.
uh by other industries.
Right.
Okay.
And this is the plan for scale up.
Everybody that enters the field comes up with a new acronym, and it's becoming a bit of a joke.
Because they want to separate themselves apart from everybody else.
Well, and their idea, of course, is more on target. And Mitch Swartz jumps up and down about LANR because he thought of that and insists on it, to the point of it becoming,
Mitchell Schwartz's reaction.
funny, sort of funny in a tiresome way. And every one of the International Advisory Committee meetings 10 times greater than the energy density of a chemical reaction. That's what makes it important.
I see. All right, so we can't really get away from that.
Well, for Joe's six-pack, we don't have to say nuclear, though.
Well, which is what the reason. And the problem I have with acronyms is this field has spawned more acronyms than any other ever. I would think there's got to be at least 30 operational acronyms that we sit in. Somebody comes up with, well, we've got to get the nuclear out of the name, and we worked hard. CMNS does have N in it, but nuclear science is a little kinder sounding than nuclear energy. But you get to call it what you want. Controlled electron capture, I'd be happy enough with that. But comes the time for licensing, and the authorities get.
SRI International in Menlo Park, California. Signing in through the security guard in front. Have to be in the system, give them at least a 24-hour notice to get in.
Get involved. There's no disguising the fact that the power and strength of this effect is its nuclear parentage, and that is the thing that makes it important. If it wasn't nuclear, it wouldn't be important. Unless you believe Blacklight Power, who are going to run a demonstration on the 28th of January, producing 10 megawatts from a 1-foot cube.
Yeah, got a note on that one this morning.
Really? Where's that?
And anyway.
So